So I'd like you to imagine that you are a toddler playing with boxes of Lego. So imagine a child makes a bear with Lego and then decides to take the bear apart and make a snake. Notice that we use the same pieces of Lego to make the bear and snake. We used 5 red pieces and 2 blue pieces. Then the mass of the bear would be exactly the same as the snake. The law of conservation of Lego states that whatever Lego you start out with is the Lego you end up with, except it's rearranged. The law of conservation of mass states that in a chemical reaction, atoms are rearranged and the mass of the reactants equals the mass of the products. Turning the bear into a snake means breaking the bonds and rebuilding the bonds into something different. And that is what a chemical reaction is in essence, breaking and making bonds. Now imagine you have a box of water compounds. Remember, water is made out of hydrogen and oxygen. Its formula is H2O. So you have a box of H2O and you have another box, and the other box is sodium or Na. And now, with these reactants, you're ready to build. So the reactants are H2O plus Na. And when the kid breaks the bonds and remakes them with access to all the Lego in the boxes, then what we're doing is we're taking the sodium, the Na, and attaching it to 1 oxygen and 1 hydrogen, and we're putting the 2 hydrogens together as well to make your product. So take a look at what we just did. So, how many pieces from each box were used to make these products? Is there enough here to go and make this? It is actually not balanced yet. Let's balance this reaction. We ask how many pieces of reactants are needed to make the products with absolutely no leftovers. Here, there is not enough hydrogen to make this product. For everything to be balanced, you actually need to start out with 2 NAs and 2 pieces of water in order to make 2 NaOHs and 1 pair of H's. So take a good look at the reactants and products. We use 2 H2Os plus 2 NAs, which gives you 2 NaOH plus H2. And now we have the same mass of reactants and products. Let's try another one. Our reactants are hydrogen in pairs, oxygen in pairs. These are in our initial boxes of Lego, H2 and O2. H2, the little 2 means that there are 2 pieces of hydrogen attached together, and the little 2 in front of the oxygen means that there are 2 oxygens together. So the reactants are H2 plus O2. And what do we make out of this? We make some water. We make some H2O. This is the product. So to balance this, we ask how many of each reactant do we need to make the product? Well, in this situation, if we used these reactants, then we can make this product. So now we're balanced. So you can see we are using 2 H2s and 1 O2, and we get 2 H2O. So now this is a balanced equation. Do the masses of the reactants equal to the products? Yes. Here's another example. Imagine you had as the reactants these pieces of Lego, and we make a product that looks like this. So our Lego would be H and Cl and Mg and O, and the reactants are HCl and MgOH2. Notice the way we write this formula for magnesium hydroxide, MgOH2. So the question is it balanced? How many pieces of the reactants are needed in order to make the products? So you will see that we actually need 2 HCl's in order to make the product, and we will end up with 2 waters in the end. And now this reaction is balanced. In fact, we can take the reactants, we can rearrange the reactants in order to show that it makes the products. Let's try this. So for example, we can take the reactants apart kind of like this. We can take an OH off of the magnesium, and we can take an H off of an HCl, and we can make a water. And we can make another water. And then we can take the magnesium and attach it to the Cl's, and look, reactants and products are now exactly the same. So if we were to write this, let's write this now. We say that there are 2 HCl's added to 1 magnesium hydroxide, MgOH2. And then that creates an MgCl2 plus 2 H2O's. And now this is a balanced equation. Now it's balanced.